Okay, we left off with number 13, is that correct? Okay, so on number 13, thank you for listening. On number 13, we have the square root of 24, x to the 7th, y to the 7th, over the square root of 2xy. So what we can do is, remember when you have a radical over a radical, think of it as a radical over the whole fraction. So you've got this 24x to the 7th, y to the 7th, over 2xy. You can reduce this before you take the square root. So how many times will 2 go into 24? 12 times. So we're going to reduce that. 2 goes into 24 12 times. You've got x to the 7, you've got x to the 1. When the numerator, the exponent, and then here in the denominator we have an exponent. You subtract those exponents when the base is the same. So 7 take away 1 would be what? So that would be x to the power of 6. Same thing with the y here. We have y to the 7th over y to the 1. You just subtract those, and what do you get? Y to the power of 6. So notice in the denominator now, what do we have in the denominator? 1. When everything reduces, you still have a 1. So really it's not a fraction anymore. So we have the square root of 12, x to the 6th and y to the 6th. These exponents are both even, so you know they're coming out because the index is 2. But the 12, is that a perfect square? So that's going to be 2 times 6. 6 is 2 times 3. So you have a 2, a 2, and a 3. Yes. 2 out, 3 stays in. The x to the 6, 6 is going to divide by 2. The y to the 6, 6 is going to divide by 2. So what do we have? 2, x to the 3rd, y to the 3rd, square root of what's left inside? 3. Done. Okay, on 14. Okay, on 14 we have 5 square root of 48. And 7 square root of 27. What can we bring out of this radical? We've got 2 times 24, 2 times 12, 2 times 6, 6 is 2 times 3. Check yourself. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 3 is 48, right? Your index is 2, so you have 2 2's, 2 2's, and a leftover 3. What's already on the outside? So 5 times the 2 that we bring out times another 2 that we bring out, and the radical 3 is still there. On the second term, you have 27, which is 3 times 9, and 9 is 3 times 3. So there you have a pair of 3's with the 3 left over. The 7 is already out. We have a 3, square root 3. So far, so good? So we have 5 times 2 is 10. 10 times 2 is 20 square root of 3 plus 21 square root of 3. Are they like terms? How do you know if you have a like term? The index and the radicand. Okay? Your index and your radicand have to be exactly the same. So the index is 2, the index is 2, the radicand is 3, the radicand is 3. These are like terms. You take the 20, You add it to the 21. Finished. Feeling smart? Okay, on 15. You have 6 take away the square root of 3, and you are multiplying that by 7 plus the square root of 3. Anybody remember what we're going to do? Yes. First, outside, inside, last. Okay? Let's make a happy face. 6 times 7. 42. That's your first. Outside, 6 times square root of 3. Inside, the negative square root of 3 times 7. Last, negative times a positive is a negative. And the square root of 3 times the square root of 3 is 3. Remember, the square root of Kelvin times the square root of Kelvin is Kelvin. That's right. Okay, so combine your like terms. You have a 42 with a like term of minus 3. What do you have? 39. Then you have 6 square root of 3 take away 7 square root of 3. Yes, and you can put the 1 there, or you could just write minus square root 3. And that's it. Feel confident? No, ma'am. All right, let's look at 16, where we're going to rationalize the denominator. Y'all love those. Did you say hate? Don't be a hater. Okay, we have 8 plus 3 square root of 2 over 7 minus square root of 2. Are we allowed to have the radical on the bottom? No. So we are going to rationalize the denominator. How do we rationalize the denominator? Okay, so you're going to multiply by the complex conjugate of 7 minus square root of 2. So you're going to be multiplying this by keep the first term the same, but we're going to use the opposite sign of the second term. So far, so good? Whatever you put on the bottom, you want to make sure that you also put on the top. That's because you're multiplying by a 1. You're changing what it looks like, but you're not changing how much it is. Gentlemen, you getting this? Okay. So, for the top, first, outside, inside, last. 8 times 7. 8 times the square root of 2. Square root of 2, you did it right. Okay, inside, 3 square root of 2 times 7. Last. Now be careful with this one. Ian, you watching? You're going to multiply the 3 times the 1, giving you a 3. But the square root of 2 times the square root of 2 is, so that's really, I'm waiting. Good job, Razzie. All right, on the bottom, 7 times 7. 7 times square root of 2. Negative square root 2 times 7. And negative square root of 2 times square root of 2 is a negative. Good job. All right, let's clean it up. On the top, 56 plus 6. 8 square root of 2 plus 21 square root of 2. Great. All right, on the bottom, the 7 square root of 2, take away the 7 square root of 2. So we don't have a radical on the bottom anymore, which was our goal. Our goal was to get rid of the radical off of the bottom. 49 take away 2. Looking at our 3 terms here, can we reduce this? Do they have a common factor? No. We're done. With that problem, not for the day. Number